こんにちは。名古屋大学研究フロントラインです。名古屋大学の最近の研究の話題をお届けしています。運営の丸山です。今回は海外出身で命題で活躍中の研究者の一人、トム・バックスさんにお話を伺いました。トムさんはオランダ出身で天体物理学のポスドク研究員です。宇宙望遠鏡と地上望遠鏡を駆使して銀河の形成や進化を探る研究をしています。今回研究についてはもちろん日本に来るきっかけになった日本人研究者との出会いや日本での生活についてお話を伺いました。英語でのお話の後に日本語のサマリーを入れていきます。Welcome, Tom.
Yeah, thank you very much for inviting me.
First, would you briefly introduce yourself?
Yeah, so I've lived in Nagoya for 3 years now, and I've moved in the late part of 2018 to the lab run by Yuichi Tamura, where I study very distant galaxies.
Are you enjoying?
Very much so. I think the quality of life I'm experiencing here is very high.
トムさんは3年前に来日して名古屋大学では田村陽一准教授が主導する天体物理学教室に所属しています。日本での生活はクオリティが高くて楽しんでいるとのことです。Why did you choose Japan to conduct your research?
So I've always had a strong connection to Japan, be it when I was small that I liked TV shows such as Pokemon, or when I practiced judo when I was a child. And at university I got into Aikido, and I met a researcher where I did a research project who was natively from Japan. I got to visit.
What's his name?
Yeah, Akira Endo.
Dr. Akira Endo.
Yes, exactly. I met Akira Endo at Delft University in the Netherlands. He invited me to go to Japan on a work visit for 2 weeks. And that was my first experience here.
That was 2004.
2014. I went to visit Japan, and that was a great experience. And when a position opened up in Nagoya, I applied and I got the position, and I've been very happy with that decision ever since.
トムさんは小さい頃から日本の文化に親しんできたということですが、オランダの大学時代に日本人研究者の遠藤明氏に出会ったことがきっかけで日本を訪問する機会を得ました。その後、名古屋大学の公募を見つけて応募し、採用されて日本で研究することになったそうです。You were involved in the project called DESHIMA?
Exactly. So this is the project that Akira Endo led, or is still leading. It's named after a famous port in Nagasaki where the Dutch and the Japanese traded for over 200 years.
Oh, such a perfect name for the project.
I'm very amazed at the historical relevance of this name. Yeah, and the goal of the instrument that he's building, so it's a bit like maybe a camera consists of a lens and of the camera system itself. So we're building the camera system in Delft, and together in Nagoya we're still collaborating on this. The idea is to be able to very easily find the cosmological distance between us and these very far away galaxies.
Okay, so DESHIMA is not a telescope, but a detector, can I say?
Exactly.
Yeah, to install on a telescope.
Exactly.
トムさんは学生の頃から遠藤氏が主導するDESHIMAというプロジェクトに参加しています。DESHIMAというのは望遠鏡に取り付けるカメラシステムのことで、銀河までの距離を簡単に測れる装置です。DESHIMAという名前はオランダと日本が貿易を行った長崎の出島にちなんだものだということでした。What is your typical workday like?
My typical workday often starts off with a cup of coffee to make sure I'm nice and awake. I try to write a lot of research proposals to get more observation time on various telescopes, on optical telescopes, or on space telescopes, or far infrared telescopes. In total, in my time in Nagoya, I've written around 50 of them, so I'm becoming slightly an expert on writing research proposals.
50 proposals in 3 years?
Yeah.
roughly 16 or 17 proposals a year.
Yeah, that sounds about right, yes.
How much work do you need to write a proposal?
It varies significantly. Sometimes a research proposal is an iterative project where we use the work that we have previously done and try to improve it incrementally. And those are relatively easy. And sometimes we try something completely new and see whether the people who own the telescope also agree with us that it's a fantastic idea. Yes.
Did you apply to the James Webb?
Yeah, we applied for several projects. One of them got accepted. It should be observed by the end of the year. Yes, yeah, it's a truly fantastic opportunity. Moreover, James Webb has a policy where the first half year of data or so will be completely restrictionless. So there was no need to apply for certain science goals where we can just wait for the data to be taken and we can immediately download it without having to write a research proposal.
Because it's the beginning of the project?
Exactly. Those are very important early science results that James Webb will be able to provide. And at the same time, because the science is so important, it is important that every researcher should be able to access it and do their research on it.
今の研究者ライフについて聞きました。非常に多くの時間を望遠鏡の観測提案書を書くことに費やしているということでした。日本にいる3年間でなんと50もの提案書を書いてきたそうです。提案書によっては過去の観測に基づくものもあれば、全く新しいアイデアを提案するものもあって、作業量は一概には言えないとのことでした。ジェームズ・ウェッブ宇宙望遠鏡の観測も採択されたそうですが、実はジェームズ・ウェッブ宇宙望遠鏡のプロジェクトでは、初めの半年間は全ての人に公開されるデータがあるということも教えてくれました。You said you like coffee.
Yeah, exactly.
For those who don't know about Nagoya much, Nagoya is known for its unique coffee culture called morning.
Yeah.
Have you tried that?
Yeah, I've had some breakfasts here.
Okay, yeah.
Been,
when you get a cup of coffee, you get free breakfast.
Yeah, the shokopan or the salad. Yeah, the Japanese bread is a completely different experience from Western bread, but also very delicious.
コーヒー好きな一面も聞いてみました。名古屋のモーニングにも行ったよとのことでした。Can you tell us what you are studying?
So, in my research, I try to connect the very early moments of the universe to the environments we see around us today. And I do that by studying the evolution of galaxies across cosmic time. So the universe started off as a homogeneous cloud of gas, and slowly this gas collapsed into galaxies where a lot of stars were formed. And many of these processes that happened are still big mysteries to us today, and especially in the very distant universe, these processes happened a lot faster and a lot more intensely than what we can study in the universe around us.
So it sounded like galaxy is a key to understand the universe and how it developed.
For me at least, this is a key point to understanding it.
銀河の形成や進化についての今の研究について聞きました。ほぼ均一なガスまたは雲が崩壊して星や銀河が作られたそのプロセスというのは今も謎で、宇宙が始まって間もない頃からどのようにして今の宇宙の姿になったかを知りたいということです。How do you approach that topic?
So I use telescopes that are in space, such as the Hubble Space Telescope, Herschel, but also the James Webb will be very useful. And at the same time, I use telescopes that are on the ground to provide a natural complement to the space-based studies.
ご自身の研究テーマにどうアプローチするのかを聞きました。具体的にはハッブル宇宙望遠鏡やハーシェル宇宙天文台、ジェームス・ウェッブ宇宙望遠鏡といった宇宙の望遠鏡と地上の望遠鏡を使った観測をしているそうです。I guess ground telescope and space telescopes are very different in many ways, and I think you need different skills for observation and analysis?
So the focus that a telescope in space has is often different from one that you can leave on the ground. You don't have to worry about the weight for a telescope on the ground. You can build it as large as you want, and your development can be faster on the ground. So I think there's a good reason to go into space to get the highest quality image of several sources or several galaxies, but on the ground you can study many more at the same speed as well.
So that's the advantage of using both telescopes.
Yeah, there's a natural complement to using both of them.
宇宙望遠鏡は質の高い画像が撮れるという利点。地上望遠鏡は重さや大きさの制限がなくて比較的スピーディーに開発できるという利点があります。連携して観測することでお互いを補完できるということです。Using telescope on the ground and in the space, can you give some example using that approach?
Yeah, so one of the best examples of this is 25 years ago now, Hubble looked at a dark piece of the sky, looking for absolutely nothing. We didn't know what was there. And for 10 straight days, they observed this blank piece of sky. And about half of the researchers didn't believe that there was going to be anything in the picture. But when the picture was developed, they saw over 3,000 galaxies in this small region of the sky. So initially people didn't think that such galaxies could exist so far back into the cosmic past, and they were completely surprised. That was the first discovery. And then the second discovery happened when some new technology allowed us to look in the far infrared wavelength ranges that look straight through dust clouds that can obscure newly formed stars. So a group of researchers looked at exactly the same spot of sky with this telescope, and instead of seeing 3,000 galaxies, they only saw 5. But these 5 galaxies were nowhere to be found in the Hubble field, in the optical field. And together, combined, these 5 stars were brighter than the 3,000 stars that were seen in the optical image with Hubble. So this showed that not only are there more galaxies than we expect, there's also galaxies that we will have to work at very hard to detect. And these are equally important to understanding how the universe transitioned from gas into stars and dust and planets.
Did the finding encourage you to go into your research area right now?
I think it's a very interesting point to this research field that you cannot rely on past assumptions, not because you detected something to be a certain way a while ago, that it now has to be a certain way.
これまでに宇宙と地上の望遠鏡の観測を連携させた研究・観測の具体例を聞きました。25年前のこと、宇宙望遠鏡と地上望遠鏡で同じ空の領域を観測したところ、地上望遠鏡では何も見えないようなところに宇宙望遠鏡では3000個の銀河が見つかったそうです。宇宙望遠鏡の視力が良いということですね。また同じ領域を地上望遠鏡で新しい技術で遠赤外線で見ると5つの銀河が見つかったそうです。この5つは極めて活動的で3000個の銀河と同じくらい銀河の歴史を知る上では重要な銀河だということです。つまり銀河の数は予想以上に多いし、一筋縄には検出できない銀河もあるということが分かった重要な観測例だとのことです。And what's your research goal?
So my research goal right now is to study these very bright, dusty galaxies that this special telescope in Hawaii discovered. And these galaxies are so rare that we can't use supercomputers to simulate how they look like. We really need to go and observe as many of them as we can to see what are their intrinsic properties. Are they all caused by 2 galaxies colliding and producing a lot of dust, or is it a very special phase of galaxy evolution that causes this dusty starburst to occur? Currently we don't know, but with the telescopes that we now have, both in space and, for example, in Chile, there's ALMA, we can now really try to look for the answer in samples as large as 300 of these galaxies or so. So it's a very exciting time.
You can't depend on computers, even today. And you really need to look at the sky, the real sky.
Exactly.
今、トムさんが研究で目指しているのは、ハワイにある望遠鏡が発見した明るくて塵に包まれた銀河を理解することです。これとても珍しくて、コンピューターシミュレーションの手法が使えないので、現地で銀河をできるだけ多く観測して、その本質を見ていくそうです。Okay, what's the most exciting moment in your research career so far?
So, with Hubble looking as far back as possible and finding these very faint galaxies, really in the cosmic dawn when the first galaxy started to form, and we then look for the presence of dust. We found a little bit of dust at one color, and when we shifted the colors that we wanted to look at slightly, we failed to detect any dust at all.
You failed.
Or, yeah, we succeeded in not detecting dust, or we failed in detecting dust. Sorry, that's complicated. We didn't detect any dust in this galaxy at that color, which means that the bulk of the emission, the bulk of the light must be at the shorter wavelength, at the bluer colors of this galaxy. And this has dramatic cosmological implications on how galaxies evolve really in the early stages of the universe. First we thought there isn't enough cosmological time to form dust, and now we have again had our expectations overturned. We see dust is extremely important in the early universe. It was truly surprising.
これまでの研究で一番ワクワクした瞬間について聞きました。ハッブル宇宙望遠鏡で観測した宇宙誕生の頃の遠い銀河に塵を見つけたことで、宇宙初期に塵がいかに重要だったかを示せた成果だったとのことです。So what is your future direction like?
So my future direction would be, or my dream future direction would be to use the same type of galaxies that James Webb will now uncover. These will be much, much further away. And to study their intrinsic properties using radio telescopes and far-infrared telescopes such as the ones in ALMA in Chile, to find out the intrinsic properties and find a complete perspective on how the universe evolved from when it was very young until the current day around us right now.
Alright, good luck!
Thank you.
I will look forward to hearing. 研究の今後について、ジェームズ・ウェッブ宇宙望遠鏡が観測する非常に遠い銀河を電波望遠鏡や赤外線望遠鏡で観測して銀河の本質を探していきたいということでした。You have research opportunities all over the world. It's very possible that you leave Japan sometime in future. But what do you think? What are you gonna miss about Japan?
I think the convenience of living in Japan is one of the most, or one of the things I will miss most about living in Japan.
Convenience.
Such as a convenience store exists around every corner. Onigiri exists everywhere that can solve any problems of a little bit of hungriness. I love kotatsu as well, but perhaps I can take one with me wherever I happen to move to.
Okay, thank you so much, Tom. It was fun and so nice to know that we have such a wonderful international researcher here.
Yeah, thank you for the opportunity to talk about my research. I really appreciate it.
I hope you continue enjoying life in Japan.
Me too.
日本の生活の便利さとこたつがとても気に入っているというオランダ出身のポスドク研究員トム・バックスさんのお話をお届けしました。今回はここまでです。最後までお聞きいただきどうもありがとうございました。またぜひお越しください。